So next coming to uh, the variable speed. So what is variable speed? Where a body covers unequal distance in equal intervals of time. Okay, where the distance covered will be different in each second. Okay, so we call that type of speed as variable speed. Okay, so we just also went through the about the graph. So you can see there the distance versus time is a, it's not a straight line, it is a curve. Okay, you can see there it is the distance covered in a time interval, it is increasing. Okay, so hence we conclude that for a variable speed, when you go through the graph, say the distance is no more proportional to time. Correct. So that is regarding the variable speed. Okay, so next coming to this average speed. Average speed is what? Where a body, when a body moves with the variable speed, then the average speed of a body is calculated as total distance traveled divided by total time taken. Okay, so if you consider total length, total distance or total path length we call. So if you consider that as delta x, and in a time interval of delta t. Okay, hence we can write the average speed as v bar or v subscript av is equal to delta x divided by delta t. Okay, and we also just went through about two different cases when the body covering different distances with different speeds. So the equation that comes out to be as v average is equal to 2 into v1 v2 divided by v1 plus v2. So next second case, second case was where a body covers equal distances with the speeds v1 v2 and v3. Okay, so the same thing just we have applied for a where a body covering this speed with v1 v2 v3 covering a distance of s1 s2 and s3. Okay, so this is regarding the average speed of two different cases. Next coming to instantaneous speed. What is instantaneous speed? Instantaneous speed is nothing but the speed of an object at that instant of time. Okay, at that moment of time, what we call that itself is called as the instantaneous speed. And the instantaneous speed is mathematically we are going to write that one as limit delta t extends to 0 into delta s divided by delta t, that is nothing but equal to ds by dt. Okay, so this was regarding the instantaneous speed, right? I think till here we discussed in the last class, right? So in case if you have any doubts regarding the last class, you can ask, or else we will move to the velocity. Any doubts? Okay, fine. We will move to the next, that is velocity. Okay, so how we are going to define the velocity? Velocity is nothing but the displacement of a particle or body per unit time is called the velocity of the body. So velocity v is equal to displacement by time. Okay, so that displacement is nothing but written as delta t divided by in a time interval of delta t. Okay, so displacement delta d in a time interval of delta t. Okay, so the SI unit of this comes out to be as meter per second. Okay, so the SI unit is meter per second, or also it is expressed as kilometer per hour. So the velocity is a vector quantity. Okay, so velocity is a vector quantity, and coming to the dimension formula, I'll come to that later. Okay, so this is regarding the velocity. Okay, and the velocity can be positive, negative or 0. Okay, why is that? Because the velocity depends upon the displacement, right? As we have just gone through displacement, when the displacement is negative, when the displacement is positive, and when is the displacement is 0, right? So since this velocity depends upon since this velocity depends upon displacement, right? Velocity is equal to displacement by time. So hence even this velocity will be positive, negative and 0, it can be. Okay, so this is regarding the velocity. So now next Coming to this uniform velocity, it is same defined as in the previous case what we have defined uniform speed. Okay. Similarly, a body is said to move with uniform velocity if it covers equal displacement in equal intervals of time, howsoever small these intervals may be. Okay. So we are covering equal displacement in equal interval of time. If that is the case, we call that velocity as uniform velocity. Okay. So next is nothing but non-uniform velocity, or we call that one as variable velocity. So when do you call that velocity as a variable velocity? When it covers unequal displacements in, or equal displacement in unequal intervals of time. Okay. So where a body is covering equal displacements in unequal intervals of time is called as variable velocity or non-uniform velocity. So next, coming to this average velocity, how we are going to define this average velocity? So in order to express this average velocity in mathematical form, we are going to take, let x and x dash be the displacement of the object at a time t and t dash. Okay. So it is nothing but, let a body moves from x to x dash. Okay. So body, now the body is at position x at a time t. So after some time the body is at x dash, at a position of x dash in a time interval of t dash. Okay. In that manner you have to understand. So next, the average velocity of the object in a time interval from t to t dash can be written as v average is equal to x dash minus x divided by t dash minus t. That is nothing but, x dash is what? Final position of the body. X is nothing but initial position of the body. Okay. So that itself, x dash minus x is nothing but, we write that one as delta x. Similarly, t dash minus t is nothing but, we can write that one as delta t. So that is nothing but taken as total displacement divided by total interval, total time interval. Okay. So this is regarding the average velocity. Next, coming to this instantaneous velocity. When the velocity of a particle is variable, then instantaneous velocity of a particle is defined as the velocity of the particle at any instant of time or at any point of its path motion. Okay. It is same as that of what we have studied in the case of instantaneous speed. Okay. Only the thing is, in place of speed we are replacing the velocity. Rest of the things are one and the same. Okay. So that is nothing but, what do you call this instantaneous velocity? At any, the velocity at that instant of time or at that moment of time itself is called as instantaneous velocity, and that instantaneous velocity is written in mathematical form as v average is equal to limit delta t extends to 0 into delta x divided by delta t is equal to dx divided by dt. Okay. Where dx and dr is nothing but same as that of delta x divided by delta t. Okay. So this is regarding the instantaneous velocity. Okay. Velocity, uniform velocity, variable velocity, average velocity and instantaneous velocity. So just go through about this velocity. Okay. So I'll just give you a few minutes, then we will move to the difference between, what is the difference between the speed and velocity. Just go through everyone. Okay, fine students, any doubts? Okay, fine. We'll move to the next. There is a difference between the speed and velocity. Okay, so again about the speed and velocity, okay, they may ask this difference in your examination for 2 or 3 marks. Okay, so see here, the first difference is nothing but speed of a body is the distance traveled by it per unit time. Okay, that is the definition, right? Definition of a speed, distance per unit time. So coming to the velocity, it is nothing but displacement per unit time, correct? Displacement of a body per unit time. So that is the first difference. Definition itself is the first difference. Okay, so next, speed of a body tells nothing about the direction of a motion of the body, whereas the velocity tells the direction of motion of the body. Okay, so as we know that since the speed is a scalar quantity, it only says about the magnitude but not about the direction. But here velocity being a vector quantity, it says both about magnitude and direction. Okay, so that is the second difference. So next difference is speed of a body is always positive and velocity of a body may be positive, negative or 0. Since we know that speed is nothing but depends upon the distance, right? So we have gone through that speed is always positive, it can never be negative and 0. Okay, so hence even the speed is always positive. Coming to the velocity, since displacement can be positive, negative or 0, so hence velocity is also velocity can also be positive, negative and 0. Okay, so that is the third difference. Next, fourth, speed of a body is equal to or greater than the velocity of the body, whereas velocity of a body is equal or less than the speed of the body. Okay, so why is that we say that speed of a body is equal or greater to the velocity of the body? Because see, velocity always depends upon the displacement. So displacement is nothing but what? It always depends upon the shortest path. Okay, it always depends upon the displacement always depends upon the shortest path. That is nothing but final minus initial position. Okay, so whereas the speed depends upon the total path length. Okay, so the speed depends upon the total path length, right? So hence we say that speed can be equal or greater than velocity. Okay, but velocity is always equal or less than the speed. So that is the fourth difference. And fifth is nothing but, as usual, you know that speed is a scalar quantity and velocity is a vector quantity. Okay, so this is nothing but the difference between the speed and velocity of a body. Okay, so next, coming to this acceleration. Yeah, Rajesh, second and fifth point are same. Yeah, correct. So coming to this acceleration, what is the acceleration? Acceleration is nothing but change of velocity of an object with time. Okay, where the change of an velocity of an object with respect to time is called as the acceleration of a body or a particle we call. So acceleration is denoted by A. A is equal to change in velocity divided by time taken. Okay, so hence acceleration is positive if the velocity is increasing. Okay, so we say that acceleration is positive when the velocity is increasing. If the velocity is decreasing, we say that the acceleration is negative. Okay, so that is the sign convention where we are going to take acceleration as positive when the velocity is increasing. Acceleration is negative when the velocity is decreasing. Okay, so this negative acceleration we also call that one as retardation or deacceleration we call. Okay, so this negative acceleration is also called as by the word retardation or deacceleration. Okay, and the acceleration is a vector quantity, both it has both magnitude and direction, and the SI unit comes out to be as meter per second square. Okay, so this is regarding the acceleration. So next, coming to this uniform acceleration. Okay, so an object is said to be moving with a uniform acceleration if its velocity changes by equal amounts in equal intervals of time, howsoever small the intervals may be. Okay, so as you know that we say that the acceleration is uniform when a body covers equal amounts of when its velocity changes in equal amounts in equal intervals of time. Okay, where the change in velocity is equal in equal intervals of time, we call that acceleration as uniform acceleration. Okay, next is nothing but variable acceleration. So an object is said to be moving with a variable acceleration if its velocity changes by unequal amounts in equal intervals of time, howsoever small the intervals may be. Okay, so we call the variable acceleration, okay, where the acceleration is varying, right? So you can see there the velocity changes by unequal amounts in equal interval of time, where the magnitude of velocity okay, changes in unequal amount in equal interval of time is called as variable acceleration. So next, regarding the average acceleration, we define average acceleration as an object is said to be moving with a variable acceleration, then the average acceleration is defined as the change in velocity of the object divided by the total time taken for this change in velocity. Okay, so this average acceleration is denoted by the letter a subscript av, that is nothing but equal to change in velocity divided by time taken. Okay, so that itself is acceleration. Okay, average acceleration delta v divided by delta t. Okay, so next is nothing but instantaneous acceleration. Instantaneous is nothing but again acceleration of an object at that instant of time or at that particular moment of time is called as instantaneous acceleration, and it is always also denoted as in the same way as that of speed and velocity. So a is equal to limit delta t extends to 0, where delta v divided by delta t is equal to dv by dt. Okay, so this is regarding the instantaneous acceleration. Okay, so just go through about this difference between speed and velocity, and just go through about the acceleration. Okay, just go through for a few minutes. Okay, student, is it fine? Any doubts? Okay, so next it is regarding displacement time graph. Okay, so see here, let us see what is the importance of this displacement time graph. Okay, when a body or a particle moves with a uniform velocity in a straight line, its displacement increases uniformly with time. The displacement time graph for such motion of the body is represented by a straight line making a certain angle with time axis as shown in the figure. Okay, so you can see there, this is the graph where we have plotted for a body which is moving with uniform velocity in a straight line. Okay, so when a body is moving with a uniform velocity in a straight line, so that, as you know, that the displacement increases linearly with respect to time. Okay, so in the graph you can see the displacement is directly proportional to time, and the nature of a graph is a straight line. Okay, so where you can see theta is the angle, okay, where it is making an angle with respect to time here. Okay, so next let us see what is the importance of this. Okay, coming to this here, determination of velocity from displacement time graph. Okay, how we are going to find the velocity, how we are going to determine the velocity by a displacement time graph. Okay, that is what we are going to see here. So now I'll just read out that, consider 2 points A and B on the displacement time graph in the figure. Let t1 be the time and x1 be the displacement corresponding to the point A. Let t2 be the time and x2 be the displacement corresponding to the point B. So the displacement of the body in the time interval t2 minus t1 is equal to x2 minus x1. So velocity of the body comes out to be as displacement by time taken, that is nothing but v is equal to x2 minus x1 divided by t2 minus t1, that is x2 minus x1 is denoted by bc and t2 minus t1 denoted by ac. Okay, so coming to this figures here, so this is a straight line where it shows the displacement is increasing linearly with respect to time. Okay, and we have just marked, let theta be the angle with respect to time. Okay, so if that is the case, what we have done is we have just taken a point A here. Okay, we have just taken a point A where the displacement at point A comes out to be x1. X1 is the displacement corresponding to the time interval t1. And next consider the point B in the figure where x2 is the displacement corresponding to the time interval t2. Okay, corresponding to the time t2. Okay, so next from the graph you can say that, okay, x2 minus x1 is nothing but what? It represents the displacement, right? So initially the body was here, now it has been moved to here. with reference to A and B I am talking, okay. So initially the particle or a body was at A, now it has been moved to B. So the displacement is nothing but what? It is always we take displacement as final minus initial. So x2 minus x1. Similarly, with respect to time is nothing but you know that t2 is final time and t1 is the initial time. So t2 minus t1. So hence the velocity can be expressed as v is equal to x2 minus x1 divided by t2 minus t1 is equal to bc by ac. So next, if you calculate the slope, how you are going to calculate the slope? It is always the value of tan theta, right? So tan is nothing but what? Value of tan theta. Tan theta is equal to opposite by adjacent, right? So opposite is what? BC is the opposite, adjacent is nothing but AC. So hence the slope, okay, the slope of an displacement time graph gives the velocity of a body moving with uniform, having a uniform motion, okay. So that is what they have given here. Therefore velocity of a body having uniform motion is equal to slope of the displacement time graph. So this slope gives the velocity of a body moving with uniform motion. So this is the importance of displacement time graph, how we are going to determine the velocity of a body by using the displacement time graph, okay. Just go through about this, because this displacement time graph we are just going to make use in a last derivation, where once we start with the kinematic equations of motions, okay, which is very important. At that derivation we are going to make use of this concept, okay. So just go through this. In case any doubts, let me know. First just go through this entire derivation. Yes, any doubts? Okay, fine. So see here, the assignment for today's class will be, so just write down the difference between the speed and velocity. Okay, so you have to go through about this instantaneous velocity. Okay, just write down what do you mean by this instantaneous velocity with the equation. Similarly, instantaneous acceleration, definition plus equation. Okay, so next about this displacement time graph. Okay, just make a practice of this displacement time graph. Okay, from here to here. Okay, so I think we have just left out with 3 minutes. Okay, let me complete this velocity time graph. Okay, so see here, this is a velocity time graph. You can see there we have taken the velocity in the y axis, whereas the time in the x axis. Okay, so let us see what is the importance of this velocity time graph here. It says that when a body or a particle moves with uniform velocity, then the magnitude as well as the direction of the velocity of the body remains the same at all the point of its path. So velocity time graph for such a motion of the body is shown in the figure. Velocity time graph for the uniform motion of a body is a straight line. Okay, so see here, this graph denotes about the particle or a body which is moving with uniform velocity. Okay, so when a body is moving with a uniform velocity, so you can see there it is a straight line which is parallel to time axis. Okay, so you can see there the value of the velocity remains the same for all the instant of time. Okay, so this is about the velocity time graph for a uniform motion. Okay, so velocity time graph, so if the velocity is uniform, you can see there it is a straight line which is parallel to the time axis. Okay, so where at each time the velocity of a particle remains the same, it doesn't changes. Okay, this is only when the velocity of a body velocity of a body is moving with uniform motion. Okay, where a body is moving with uniform motion. So this is regarding the importance of this velocity time graph. Okay, so in the next class we will go through about this displacement of a particle in a given interval of time. Okay, so we will go through about the next graph in the next class. Okay, so I hope what we have just gone through today it is clear to you. So anyhow you have the notes, right? Just go through and just write down what I have said to as the assignment. Okay, just make a practice. In case if you have any doubts regarding today's class, so in the beginning of next class you can just clarify your doubts. Okay, Harsh, should we write velocity time graph? Yeah, write down that also. There is a chances of asking velocity time graph also. Okay, so next coming to Harsh itself, you have asked how is the equation of instantaneous speed derived. I have cleared in the last class itself, no need of deriving that. Okay, it is not in your syllabus, it is just a equation, just practice it. Okay, so with this thing I'm just ending up today's class. Okay, thank you.